Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll solve one problem related to velocity and acceleration. And here I have taken a question that the following cases represent the two velocities components. Determine the third components of velocity such that they satisfy the continuity equation. So the conditions are given of these two velocities. One is u equal to x square y square z square and v x y square minus y z square plus xy, and second component is v equal to 2y square and where w equal to 2xyz. Okay, so these are the two velocity components are given, and we need to find out the third component of the velocity so that they will satisfy the continuity equation. So let me start. So we know that the continuity equation we have seen that which is defined as, or which is derived, and we can write this equation like del u by del x. Three velocities in three directions will be there. Okay, del v by del y plus del w by del z. This equal to 0. See, u, v, w, these are the three velocities, x, y, z in the three directions are there. So this equation we need to consider, and we need to satisfy this equation. Okay, so first condition, what is there? This is the first condition. So let condition take condition 1. In the condition 1, what is there? U equal to x square y square z square, x square plus y square plus z square. So again we can put the value of this u in this equation. So you can directly do one thing. We'll just find out del of u by del of x. That means the derivative of this u with respect to x. If you do, then what will be there? Derivative of x square, that will get 2x, and remaining part will be 0, that will be not there. Okay, so we'll get this value del u by del x equal to 2x. Similarly, if you see the case 1, v equal to what is given? V equal to given xy square minus yz square plus xy. So this is the v value, velocity value. Now here also we can find out the velocity del v by with respect to del y. So what will get here? If you derivative of this, then we'll get 2xy, that means y square, x constant will be take out, and remaining this term, two terms, check it once y is there. Yeah, here also y is there, then we'll get minus 2zy, or 2, we can write y square. Okay, this is z square is there. No, sorry, z square is there, not y square. Yz square means we with respect to del y we can derive, so we'll get only z square because del y by del y will be there, and finally it will be xy. The value is xy, so we'll get only x because del y by del y, x will be constant, it will be taken outside. Okay, now substitute this value. If you see these two value what we got, we can put this value in this continuity equation. Okay, after putting the value, what will get? Let's put the value there, and we'll get 2x on behalf of del u by del x. Now del v by del y, we got here 2xy minus z square plus x. And what about the del w by del z? That one we can write as usual, del w by del z equal to 0. So if you keep del w by del z one side, and let's see del w equal to, or del w by del z you can write, and this all these terms you can take it to other side. So 2x plus x, that is 3x, and if you take to right hand side, we'll get minus 3x, because 3x is there, that will be taken to the right hand side, they will get minus value. Okay, now here it is plus is there, that also will be minus 2xy, and minus is there, that will be plus z square. So this is the value of del w by del z. Now same thing if I write in terms of del w only. Okay, then we can write the total whole bracket, then we can keep it del z plus z square all multiply into del z. Okay, now we need the value of actually w. Okay, now what I'll do here, I'll just integrate this equation. Integrate this equation for the both side, then we'll get integrate from this. Now again integration of this minus 3x minus 2xy plus z square into del z, okay, or dz, anything. Okay, now if you integrate these things, what we'll get finally, let me write here, w equal to integration with respect to del z. So integration of del z, this three constant value will be taken outside, so we'll get minus 3xz. Okay, this is one term. Now here it is already 2xy is there. Now again 2xy is here constant in the sense it is not related to the del z. So integration of 2xy del z, what will get, integration of del z only, 2x will be taken out. So similarly we can write 2xy integration of this del z, del we will get here. Now here we'll get z square del z integration. So this will be like, you know, zq by 3 as per the integration formula, plus we can get some constant of integration, will get some value, because some constant we know that if you do the integration whole part, then we'll get some constant. Okay, this constant actually we used to mention c in our mathematics. If you have seen c value we used to write here. So this is constant of integration. So finally what we can write, see, this constant of integration can be the function of z. Okay, can be the function of z, because we have derived the integrated with respect to del z. But this function we can be also a function of xy also. Okay, so what we'll write finally, let me write w equal to minus 3xz minus 2xyz plus zq by 3 plus function of xy. See, this is the function of xy is nothing but a constant only we have taken. Okay, so this is the value of this w, third component of this. See, third component of the velocity. Two components are given, and this is about the third component. This function of xy is nothing but a constant of integration. So this actually we cannot take this function with respect to dz actually. Z function, I told that it can be taken, but it is not able to take as a function of z. Okay, so we can write this as a function of xy. So second equation we'll see, this is the second one. So this is v equal to, it is given 2y square, and here we can directly write del v by del y. Velocity with respect to y, we need to remember like this. Velocity, y direction, what is the velocity? X direction, what is the velocity u that will be there. So del v by del y we can write, this is integration of this. So if you integrate this one, derivative of this, will get 4y. Similarly, what is the second value? W equal to 2xyz. So you can write w equal to 2xyz. Again, simply we can derive this derivative of this del w by del z. W velocity with respect to z direction. So if you derivative of this, will get only 2xy. Okay, so this is the value. Now again the same two value, this value and this value, we can put in our continuity equation. Okay, so as per the equation we know that del u by del x. So let's write del u by del x. Then del v by del y. Del v by del y we got here 4y. Similarly plus 2xy. 2xy equal to 0 we can write. Now same thing again we'll do. We'll keep this del u by del x one side, and remaining terms will take it to other side, that is 4y minus 4y minus 2xy. Okay, now again same thing I'll do. Del u I'll write, and this del x I'll take it to other side. So 4y minus 2xy whole bracket del x. Okay, now again what I'll do, integrate this, will get integration of this like previously how you did. Here also we'll do the same thing. Integration of this will get u, and this is minus 4y will be taken outside. Integration of del x will get minus 4xy, and again minus will be there, so that will be 2y will be taken out. X dx, integration of x dx, nothing but x square y by 2 again we'll get a, you know, this is constant of, we'll get it here. Okay, that is the function of constant we'll get. So here also you can write this constant of integration, we can write it. This is u equal to minus 4xy minus 2x square y by 2, and this is the function of xy. So I hope you understand how to derive this velocity function for this. This is the, for the second equation what we have derived u, because in the second equation if you see, u was not given. In the first equation w was not given. Okay, so this is our main formula. We just need to derivative of all these things. Okay, so we can see how easy it is. So easily you can derive this, you can solve this problem. And if you are having any kind of doubt regarding this problem, you can give a comment on the comment box. Thank you all.